Hello. This video will demonstrate how to use this intermediate value theorem, which we will talk about, and the method of bisections to determine or find an interval of some given length which contains a root. Okay? And we have to remember what a root is. The most important thing is to remember that a root is an x value. It's the x value that makes the function equal to 0. So I can see here that this is a root. This is my root. Okay? And the idea here, right, obviously at this x value, y is equal to 0. Well, there's a root over here, there's a root over here, there's a root over here. For this particular function, there are many roots. We're going to be concerned with this one here. Now, what we're doing is we're not finding the root, we're finding an interval. We're finding an interval that contains the root. All right? So if I look at this x value here, I can see that y is less than 0 in the function. If I look over here, and I look at this x value, I can see that y is greater than 0. And don't forget, at the root, y actually is 0. And so even though I can't tell you exactly what the root is, I can say that that root exists somewhere between this x1 and this x2, right? Somewhere in there, I don't know where, the root is going to exist. Remember, the root is the x value. Obviously, what we would like to do, we would like to make this interval as small as we can. Now, obviously, if you have a computer program, this is not a big deal. All right? Right now, the length of my interval is pretty wide. And it still gives a lot of space of where that root can be. So what we want to do is get an x2 that's even closer, and get an x1 that's even closer. We're trying to sort of capture that root. All right? So again, if we're looking at this function, again, we can see, I want you to focus your attention here at these coordinates, right? At this x value, my y's are positive. Positive, 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 positive. Come on. Positive. That's why. Positive, positive. Oh, come on. All right, we'll start here. All right, the function, the y values are negative, 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 and notice that negative 0.01, and then boom, 0.01. So it went from negative to positive, the y value did. That means y equals 0 is somewhere between there. Okay? So again, we're not trying to find exactly what the root is. What we are trying to do is sort of capture it in a very small, tight interval. Okay? So, here is the process. All right? Now, every calculator is a little different. For our class, we're using the Casio 991 ES. Different calculators, this will obviously be a little different, so you must know your calculator. I obviously don't have a computer version of this calculator, so I'm going to use Excel, but you'll see what I'm talking about. Okay, what we want to do is, go to mode 7, and that will allow us to create a table. Then you're going to be asked for an f of x. Be careful, you guys. Make sure that you're using your parentheses properly. All right? Now, let's go back to our graph. I'm looking for the root between 0 and 1. right? I know that a root exists somewhere between 0 and 1 when I look at the graph. So yes, there are other roots, but I'm going to really be concerned with 0 to 1. Okay? So we are going to start at 0 and end at 1. So our start, in this case, will be 0. My end will be 1. Now the step. This particular calculator can use a step of up to 1 to 29. So you'll have to see what the directions say. If the directions say 1 over 16, then you use 1 over 16. If it says 1 over 32, well, we can't do that. We can go to 1 over 29 and use that. Obviously, this will give us a narrower interval, which is obviously better. Okay, so again, look at the directions. Again, as we saw, and we're looking for y values where the sign changes. Then, okay, once we know where that happens, just take those x values and to create your interval that contains through. Okay, let's do a few examples. Okay, so again, I know that a root exists for this function somewhere between 0 and 1. And so what I have done is I have created a table. Of course, we're not seeing it all. Let's take that out. Yes, there we go. Okay, so I can see that I'm actually using a step of 1 over 32. 1 over 32 is 0.03125. All right. Again, you're going to use 1 over 16, 1 over 29, whatever that happens to be. You don't have to worry about these numbers. The calculator will create these numbers. And what I did over here is just create a formula, right? The cosine of 2x plus 3 all divided by x. Now remember, we saw that it's undefined at 0, so hopefully that makes sense. All right? And at my first x here, I have a value of negative 31. All right? So I can see, where does it start to turn positive? It looks like it's negative, 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 and then it turns positive. So my interval, which contains my root, is somewhere between 0.84375 and 0.875. Again, this interval has a length of 1/32, or 0.03125. Again, does that make sense, right? I can see here 0.86. Again, this doesn't give us as accurate of details as Excel, but I'm hoping you see that between somewhere there, right? 0.85 and 0.86, right? That's where my interval exists. Excuse me, that's where my root exists, and I can see that here. Okay, so that's our first example. I hope that makes sense. Let's look at another example. I'm going to tell you that you have this function e to the x over x minus 5, and there is a root that exists somewhere between 2 and 3. And again, you won't get the graph always, but it's a good idea to see what happens. Come on, go away. There we go. So somewhere between 2 and 3 there is a root, and it kind of looks like 2.5. I guarantee it's not going to be exactly 2.5, but who knows? I don't know. All we're trying to do is find an interval that contains it. Okay? Again, in this case, as I come from the left, it's negative, 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 0, positive, 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 positive. And when I say it, I mean the y values. Okay? So let's go back here and let's look at our table. Again, notice my start is 2, my end is 3, my step was same thing, 0.03125, or 1 over 32. Okay, and I can see here You can look at my, right, this is just how Excel does it. It's e raised to the power, in this case, power 2 divided by 2 minus 5. Trust me, these are the correct values. Okay, and again, we're gonna, like we saw on the graph, negative, 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 and it turns positive. And again, just like we said, it's somewhere around 2.5. Okay, so 2.3125, 2.53, of course I can't remember that, 53125. All right, and that is going to go to 2.5625. All right, how did I get that? I just added 0.03125. Okay, and that means that the root, that x value, is somewhere in here. Okay, simple stuff, not so bad. All right, so again, the directions might say, find the interval with length 1/16 that contains the root blah, blah, blah. I used a length of 1/32 because Excel allows me to do that. Your calculator, as I said, is somewhat limited in that respect. So you, again, the most you can go up to is 1/29, and that's pretty good. All right, let's do one more example. All right, now I know that you guys like to do your mode 5.3, mode 5.4, blah, 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 but in this case, I don't believe you have a function that allows you to do a quintic. I can see here that I do have, come on, go away. All right, I can see that, come on, very touchy. There we go. I can see that my function has a root somewhere between, has a few roots, but I am going to be concerned with this one here. Okay? You can notice what happens. I know it's between 1 and 2. It is positive, 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 positive. Right? You see that over there? 0.1, then 0.01, which is good. So my root is going to be somewhere around 1.43, right? That's where it changes. Okay? So again, if I look at our Excel, spreadsheet, and I look here, again, I'm going from 1 to 2, start 1 to 2, and I'm looking for where it changes from positive, 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 positive to negative. All right, 1.40625. Okay, and that is going to go to 1.4375. So somewhere in this interval, right? Again, this is my x left bound, and this is my x on my right, and somewhere in between here, I don't know where, that's my root will exist. Okay, so again, practice with your calculator. Remember to, if necessary, such as in this case, to use your brackets properly. Right? This would be very different if the function was this, correct? So depending on what you get, you're going to have to use your brackets properly. Well, I hope that helps. Thanks for watching.